Hey everyone, welcome back to the channel where we dive deep into the cosmos and beyond. Today, we've got an exciting Q&A episode lined up, answering your burning questions about space exploration. We'll be talking about bringing the legendary Voyagers back, the Europa Clipper's fascinating power source, and the mind-blowing JWST deep field images. Stick around because you don't want to miss this galactic journey. One of the most intriguing questions we got was whether we could bring the Voyager spacecraft back to Earth. The Voyagers have been traveling through space for over 45 years, venturing farther than any other human-made object. While the idea of bringing them home sounds like something out of a sci-fi movie, the reality is quite different. The Voyagers are now in interstellar space, more than 14 billion miles away from us. Due to the immense distance and the energy required, a return journey is, unfortunately, impossible with our current technology. But even though we can't physically retrieve them, the data they're still sending back is like treasure from the stars, giving us insights into the farthest reaches of space. Next up, let's talk about the Europa Clipper, NASA's upcoming mission to explore Jupiter's icy moon, Europa. One of the big questions we received was about the spacecraft's power source. Will it be nuclear, like many deep space missions, or solar-powered? The answer is solar. Europa Clipper will use large solar panels, even though Jupiter is 5 times farther from the Sun than Earth. While it may seem counterintuitive, solar power has proven to be incredibly effective even in the cold outer reaches of our solar system. The spacecraft will generate about 600 watts of power, enough to run a couple of household appliances. This energy will help Europa Clipper study Europa's surface and possibly detect signs of life beneath its icy crust. Now, let's get into one of the most mind-blowing things in recent space news: the James Webb Space Telescope's JWST deep field images. These images have captured some of the earliest galaxies ever formed, dating back to just a few 100 million years after the Big Bang. So what exactly are we looking at? The JWST is giving us a glimpse into the distant past, allowing us to see galaxies that were once invisible to us. With its infrared capabilities, JWST can peer through clouds of cosmic dust, revealing star formations, black holes, and ancient galaxies. It's like looking at a cosmic time machine, helping us understand how the universe evolved over billions of years. Speaking of JWST, another popular question is whether this incredible telescope can help us detect life in other parts of the universe. While JWST isn't designed to find aliens, it can detect the building blocks of life. The telescope can study the atmospheres of exoplanets and search for signs like water vapor, methane, and carbon dioxide, all potential indicators of habitability. By observing distant planets, JWST may help us determine if they have the right conditions for life. It's not a direct alien detector, but it's a significant step in our quest to answer the age-old question: are we alone in the universe? Finally, let's talk about what all of this means for the future of space exploration. With missions like Europa Clipper and telescopes like JWST, we are on the cusp of answering some of humanity's most profound questions. Are there other worlds with life? How did the universe begin? Where are we headed next? The next decade of space exploration is set to be one of the most thrilling yet, as we continue to push the boundaries of our knowledge. From sending probes to icy moons to peering into the deep cosmos, the future is bright and full of discovery. One of the most common questions in space exploration is how far we can travel with today's technology. Our current spacecraft, like Voyager 1, has traveled over 14 billion miles, but even that incredible distance pales in comparison to the vastness of the universe. Interstellar travel is still a dream, as our current propulsion systems aren't fast enough to reach distant star systems within a human lifetime. However, scientists are exploring advanced technologies like ion propulsion, nuclear fusion, and even the possibility of using solar sails to travel faster and farther. These innovations could one day make interstellar missions a reality, pushing humanity beyond the boundaries of our solar system. Ever wonder how spacecraft like Voyager, hundreds of millions of miles away, communicate with Earth? It's a fascinating process. Spacecraft use highly advanced radio antennas to send signals back to Earth, which are received by NASA's Deep Space Network, DESN. The DESN is made up of giant antennas located in California, Spain, and Australia, allowing constant communication with deep space missions. However, the farther a spacecraft travels, the longer it takes for the signal to reach Earth. For example, messages from Voyager 1 take over 21 hours to arrive. As we send spacecraft farther into space, improving this communication technology will be crucial for future missions. Europa Clipper is set to explore Jupiter's moon Europa, but what exactly are scientists hoping to find? The big question is whether Europa's icy surface hides a subsurface ocean, which could potentially harbor life. Scientists believe that beneath its thick ice crust, Europa may have a salty ocean heated by tidal forces from Jupiter's gravity. Europa Clipper will study the moon's ice shell, its potential ocean, and the chemistry of its surface. This could provide crucial clues to the possibility of life beyond Earth, making Europa one of the most exciting targets for astrobiology. Space telescopes like the James Webb Space Telescope operate differently from ground-based telescopes. Because they are above Earth's atmosphere, they can capture clearer images without the distortion caused by atmospheric interference. JWST specifically uses infrared light to peer through dust clouds and observe objects that are billions of light years away. Its 21-foot mirror collects faint light from distant galaxies, stars, and planets, allowing scientists to see deeper into space and time than ever before. This advanced technology gives us an unprecedented look at the early universe, helping us unravel mysteries that have baffled scientists for decades. With all the excitement around Europa, some people wonder if humans could one day live on this distant moon. While it's a fascinating idea, Europa presents significant challenges for human habitation. The surface is incredibly cold, with temperatures averaging around 260 Fa, 160 CE. Additionally, Europa is constantly bombarded by radiation from Jupiter's powerful magnetic field, making it a hostile environment for life as we know it. However, if a subsurface ocean exists, future missions might find ways to explore it, and who knows? Perhaps one day we'll develop the technology to build habitats beneath Europa's icy crust. Many people ask how the James Webb Space Telescope compares to its predecessor, Hubble. While both telescopes are incredibly important for astronomy, they have different strengths. Hubble has been in orbit for over 30 years, capturing stunning images in visible and ultraviolet light. JWST, on the other hand, is designed to observe in infrared, allowing it to see objects that are too faint or distant for Hubble to detect. This makes JWST better suited for studying the early universe and finding planets around other stars. Together, these two telescopes are giving us a more complete picture of the cosmos. A lot of people are curious about the famous golden record aboard the Voyager spacecraft. This phonograph record contains sounds and images from Earth, intended to serve as a message to any extraterrestrial beings who might one day encounter the spacecraft. It includes greetings in 55 languages, music from different cultures, and natural sounds like birdsong and ocean waves. The idea behind the golden record was to give potential extraterrestrials a snapshot of life on Earth. While it's unlikely that the Voyagers will ever be found by aliens, the golden record remains a symbol of humanity's desire to connect with the cosmos. The discovery of exoplanets, planets orbiting stars outside our solar system, has been one of the most exciting developments in modern astronomy. Thanks to missions like NASA's Kepler and TESS, we've identified thousands of exoplanets, some of which are located in the habitable zone of their stars, where conditions might be right for life. The JWST will continue this search, studying the atmospheres of these distant worlds to see if they contain signs of water, oxygen, or other indicators of habitability. The hunt for exoplanets is helping us answer one of humanity's biggest questions. Are we alone in the universe? As exciting as robotic missions are, people always want to know what's next for human space travel. NASA's Artemis program aims to return humans to the moon by the mid-2020s, establishing a sustainable presence there. This will pave the way for future missions to Mars, with NASA hoping to send astronauts to the Red Planet in the 2030s. Private companies like SpaceX are also playing a huge role in the future of human space exploration, with ambitious plans for Mars colonization. As technology advances, human space travel will become more frequent and take us farther into the solar system. Another fascinating question is whether we could use asteroids as space stations or bases for future missions. Some scientists believe that hollowing out large asteroids and building habitats inside could protect astronauts from radiation and micrometeorites. These asteroid bases could serve as way stations for missions to Mars or beyond. Mining asteroids for water and other resources could also make long-term space travel more sustainable. While this idea is still in the realm of science fiction, it's an intriguing possibility that future generations may explore as we venture deeper into space. Gravitational waves are ripples in space-time caused by massive cosmic events like the collision of black holes or neutron stars. First predicted by Albert Einstein over a century ago, gravitational waves were finally detected in 2015 by the LIGO Observatory. These waves give us a new way of observing the universe, allowing scientists to study events that are invisible to traditional telescopes. By detecting these waves, we can learn more about the most violent and energetic processes in the cosmos. This groundbreaking discovery is opening up a whole new field of astrophysics, known as gravitational wave astronomy. As we look forward to sending humans to Mars, one of the big challenges is how to power long-term missions. Solar power is an option, but Mars is farther from the sun, so solar panels would need to be larger and more efficient. NASA is also exploring nuclear power for Mars missions, using small nuclear reactors to provide a reliable source of energy. These reactors could power habitats, rovers, and even produce oxygen and water from the Martian environment. Developing sustainable power sources will be crucial for the success of future human missions to Mars. Dark matter is one of the greatest mysteries in modern physics. Although it makes up about 85% of the universe's mass, we can't see it or detect it directly. Scientists know dark matter exists because of its gravitational effects on galaxies and other celestial bodies, but its exact nature remains elusive. Several experiments are underway to try to detect dark matter particles, but so far, it has remained hidden. Understanding dark matter could revolutionize our understanding of the universe, shedding light on how galaxies form and how the universe is structured. Terraforming Mars, altering its environment to make it more Earth-like, has long been a topic of discussion among scientists and science fiction writers. The idea is to increase Mars's atmospheric pressure and temperature, possibly by releasing greenhouse gases, to create a more hospitable environment for human life. However, the challenges are immense. Mars has a thin atmosphere and lacks a magnetic field, making it vulnerable to solar radiation. While the technology to terraform Mars is far beyond our current capabilities, some scientists believe that future advancements could make this dream a reality. Finally, let's talk about the role of artificial intelligence, AI, in space exploration. AI is already playing a significant role in missions, from processing data sent back by telescopes and spacecraft to helping rovers navigate the surface of Mars. In the future, AI could assist astronauts on long-duration missions, performing routine tasks and even helping to make critical decisions. AI could also enable more autonomous spacecraft, capable of exploring distant planets and moons without needing constant input from Earth. As AI technology advances, it will become an even more essential tool in our exploration of the cosmos. Navigating a space probe across the vast distances of deep space is a complex task. Probes like Voyager 1 and 2 use a combination of onboard sensors and Earth-based tracking to chart their course. These spacecraft rely on star trackers, gyroscopes, and sometimes even radio signals from Earth to keep their trajectory precise. Adjustments are made using thrusters to correct their path as needed. For long-term missions, this method ensures that probes remain on course despite the vast distances and the gravitational influences of celestial bodies. The ability to accurately navigate and adjust is crucial for the success of these deep space missions. Space weather, including solar flares and cosmic rays, can have a significant impact on space missions. These phenomena can affect spacecraft electronics, communication systems, and even pose risks to astronauts. For instance, solar flares can cause temporary disruptions in communication signals between Earth and spacecraft. Agencies like NASA and ESA closely monitor space weather conditions to protect missions and ensure their success. Spacecraft are often equipped with shielding and other protective measures to mitigate the effects of space weather. Understanding and preparing for these conditions is crucial for the safety and performance of space missions. The Fermi paradox questions why, given the vastness of the universe and the potential for numerous habitable planets, we have not yet detected any signs of extraterrestrial civilizations. Despite the high probability of other intelligent beings existing, we have yet to receive any signals or evidence of their presence. Various theories have been proposed to explain this paradox, including the possibility that advanced civilizations are avoiding us, that they have self-destructed, or that they are simply too far away. The Fermi paradox continues to be a fascinating topic in the search for extraterrestrial intelligence and the study of our place in the universe. Space exploration is not limited to NASA. Many space agencies worldwide contribute to our understanding of the cosmos. The European Space Agency, ESA, the Russian Space Agency, Roscosmos, the China National Space Administration, CNSA, and others are involved in various missions and projects. Each agency brings unique expertise and capabilities to the table. For example, ESA's Rosetta mission to Comet 67P and CNSA's Chang's missions to the Moon are just a few examples of international collaboration and independent achievements. The collective efforts of these agencies advance our knowledge and foster global cooperation in space exploration. Micrometeoroids, tiny particles of space debris, pose a significant risk to spacecraft. Even small particles can travel at extremely high velocities and cause damage upon impact. To protect against these impacts, spacecraft are often equipped with shielding, such as multi-layer insulation and specialized materials that can absorb or deflect the energy from micrometeoroids. Additionally, mission planners take these risks into account when designing spacecraft trajectories and positioning. Advances in materials science continue to improve our ability to protect spacecraft from these tiny but potentially dangerous particles. Space-based observatories like Hubble and JWST provide crucial advantages over ground-based telescopes. By being above Earth's atmosphere, these observatories avoid atmospheric distortion, allowing for clearer and more detailed observations. They can also observe wavelengths of light that are blocked by our atmosphere, such as ultraviolet and infrared. This capability is essential for studying a wide range of cosmic phenomena, from the formation of stars and galaxies to the search for exoplanets. Space-based observatories have revolutionized our understanding of the universe and will continue to play a vital role in astronomical research. Space tourism is no longer just a dream, it's becoming a reality. Companies like SpaceX, Blue Origin, and Virgin Galactic are working to make space travel accessible to private citizens. While space tourism is still in its early stages, offering suborbital flights and low Earth orbit experiences, it represents a new frontier in space exploration. As technology advances and costs decrease, space tourism could become more commonplace, allowing people to experience the wonders of space firsthand. This burgeoning industry could also drive further advancements in space technology and exploration. Living and working in space for extended periods presents unique challenges. Astronauts on the International Space Station (ISS) face issues such as microgravity, radiation exposure, and isolation. Long-term space habitats will need to address these challenges by providing life support systems, radiation shielding, and psychological support. Research is ongoing to develop technologies and strategies to create sustainable, habitable environments for future deep space missions, including those to Mars and beyond. Ensuring the health and well-being of astronauts is crucial for the success of long-duration space missions. Cosmic rays are high-energy particles that originate from outside our solar system and bombard Earth from all directions. These particles can be protons, electrons, or heavier nuclei and have energies far greater than those produced in particle accelerators. Cosmic rays can affect spacecraft electronics and pose risks to astronauts. Understanding cosmic rays is important for designing spacecraft and missions that can withstand their effects. Research on cosmic rays also helps us learn more about the universe and the processes occurring in distant cosmic events. Analyzing data from space missions involves a range of sophisticated techniques and tools. Scientists use algorithms and software to process large volumes of data collected by telescopes, spacecraft, and rovers. This data is often converted into images and graphs that can reveal patterns and anomalies. Advanced statistical methods and machine learning algorithms are also employed to identify significant findings and make sense of complex datasets. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.